What's up, everybody? It's Mike coming to you with some helpful tips for the new HVAC technicians out there, apprentices, as well as your trade school students. Just wanted to go over a real quick overview of how your heat exchanger works within your gas furnace. Now, this is going to be helpful for you if you're out on maintenance, if you're doing cleaning tunes or just your basic routine annual preventive maintenances for your customers. So a couple of things about your both high and low efficiency furnaces. Anything that is considered an 80% or lower furnace is kind of considered a low efficiency furnace, and 90% or above is usually what we're talking about when we talk about a high efficiency furnace. Either way, you've got return air coming in from the house, returning to the furnace, being supplied to the house through the blower motor, being blown through the heat exchanger up into, again, the supply vents inside. You've got, of course, on the front of your furnace, you've got a combustion chamber where natural gas or propane, sometimes oil, but typically natural gas or propane is going to be burned in a combustion chamber where it's going to be drawn through the tubes and bends of a heat exchanger and eventually to be exhausted out the house through the flue. With a older, lower efficiency furnace, 80% or less, your heat exchanger would be connected directly after a few bends to your inducer or your natural draft flue. But with the inducer style, you would be basically sucking the hot gases and the unburned natural gas and CO2, which is one of the two byproducts of the combustion process, out into the atmosphere outside. So if you ever put your hand on the flue pipe, the metal flue pipe of an older furnace, you'll feel that they get pretty darn hot. And in fact, not a few of us have put our hand out and grabbed that a few times on a running furnace and have burned ourselves a little bit. It doesn't really feel great, but there's a lot of heat that's being lost there and just spewed outside. You're literally paying to heat the outdoors. So what they've done is taken another heat exchanger with now fins, slowed down the volume of air by making smaller tubes, and the secondary heat exchanger looks a lot like a evaporator coil on your air conditioner. So as the hot gases are being sucked by the inducer motor through the heat exchanger, it encounters now a smaller area. Everything is cooled. Carbon monoxide and water is the second byproduct of the combustion process, are now separating out, and as it travels, the velocity is slowed down, but in order to still concentrate that heat, we now run through the secondary heat exchanger, which has smaller tubes and fins, so that as air is being blown from the home and by the blower motor up into the secondary heat exchanger, there's now more opportunity for heat to be exchanged out into the house's supply air. Finally, the combustion gases terminate at the end of the secondary heat exchanger, where, just like with the older, less efficient furnaces, is being drawn up through the exhaust. The other difference with a high efficiency furnace, you'll notice here on our diagram, is that we have a drain. So again, one of the byproducts of the combustion process is water. So that being the case, as the flue gases are escaping, obviously the water is still left in the bottom, and that would just continue to collect. On a high efficiency furnace, you will see coming off of your evaporator coil, there is, of course, a drain for the condensate line, but then there's usually a T or a secondary means of connecting into the drain, where the drain from the secondary heat exchanger is now able to continue, and it usually has its own trap. Sometimes it's internal, and other times it's actually outside of the cabinet of the furnace. But either way, that drain must be allowed to drain away the excess water that's generated from that combustion process. So in this, we have an entire loop from gas combustion, and of course we're missing some parts. We don't have the pressure switch or the gas valve or anything represented here, or the burners, but a couple of things to note is when you're out on maintenance, if your furnace is not firing, you may have a clog in this water drain, or the trap, or if it's the first time that the furnace has been run for the season, it may have a problem with igniting if that trap is dry. So if that trap has gone dry, you may need to actually put water in it before it'll actually stay lit. In fact, that's also a note on install. If you've installed a new furnace, oftentimes, in fact, it's usually always a good idea to just go ahead and prime that trap to make sure that you don't have any problems with your initial startup. The other thing to note is if you're out on maintenance and you see that you're having trouble starting up or maintaining ignition, check that your flue isn't clogged. You know, birds will build nests inside of these. You'll also find that children have come, especially if you have, like in my house, your flue is actually terminating at the foundation of the house. It's very easy for a child to, you know, pick up their little toys or sticks and rocks and stuff those into the vent. So that's just, that's something to make sure that you're checking. So the other thing to check, of course, on maintenance is combustion analysis. You know, you should at the very least take a carbon monoxide detector and test the supply vents for carbon monoxide levels to make sure you don't have cracks or pits in the heat exchanger. If you do, pardon my cat, if you do, then that creates a dangerous situation for your customer. So make sure that you are doing a proper combustion analysis and or CO2 detection, or CO detection, excuse me, before you deem your furnace ready for the next season. But that's just a quick rundown on some things to check. And again, as I said before in another video, you want to make sure that you are cleaning that squirrel cage, pulling the fan shroud out, and sticking your head into this compartment and looking up at the bottom of that secondary heat exchanger. If there is dust, hair, fur, whatever that collects, you know, people with cats, such as him, Ruben, I'm watching you, buddy. Better behave. But if you have folks with pets, you'll see that the bottom of these fins do tend to get clogged up. You'll want to take your coil brush with you on maintenance and not only clean the fins of the blower wheel, but you'll want to clean that underside of that heat exchanger. But hey, I hope that was helpful, guys. If you have any other video suggestions or topics that you'd like to go over, feel free to send me a message. And, you know, as always, be safe out there. Have a great day, and we'll look forward to talking later. Bye-bye.